Hello my friends and welcome back. I've just got a brand new tool. It's a tool I never thought that I would possess, but for this project it is exactly what I need. So let us get straight into it and show you what we're going to be doing today. So this is a Sharp EL556G calculator released in 1995. I bought this at the end of my high school career, at the end of high school, and for the age or the time that it came out, it had some really nice features. I was doing a lot of programming, so it has decimal to binary conversion, decimal to hexadecimal, decimal to octal for, I guess, reasons unknown to me. It also had other nice features compared to the standard scientific calculators of the day. Like it had 6 memory banks, so you could put a number in, store in, and then you can see there's A, B, C, D, E, and F. And it had its main, your standard M plus memory bank. So you could put like 85 store in A, and it would store that there, which was great if you were doing long equations and you wanted to store your numerator in one variable, calculate your denominator, store that in another one, and you could just go recall A divided by recall B and get your answer. The other thing which made this really nice and still makes it very useful today is it's got 32 built-in physical constants. So that's things like the value of E, Euler's number, it's got G, the gravitational constant, mass of electrons, mass of protons, there's probably, let me have a look here, there's probably Avogadro's constant and various other things that you would use in maths and in physics. It's also got 32 conversions, which I used to use all the time. Standard things, inches to centimeters, miles to kilometers. That is actually really handy for me since I've moved countries and I've gone from a metric country, South Africa, to a more imperial country, the United Kingdom. So luckily we still use Celsius here as a temperature unit, but when I see guys on YouTube talking in Fahrenheit, then it's nice to be able to do those conversions quickly. And yeah, when you talking about your cars with your friends in South Africa, we measure everything in kilowatts, car power. Whereas it seems here in the UK everything is done in bhp, brake horsepower. So yeah, I normally then convert horsepower or brake horsepower back to kilowatts to tell my friends what kind of power I'm getting out of my vehicles. So yeah, absolutely great calculator for the day. My best friend got one of these. It was super thin, super smart for the time. I instantly fell in love with his and I said, I have to get one of those for myself. So quite a funny story. What am I, 16? And I phoned a department store which was about a 3 or a 4 hour cycle away, and a much further distance than I had ever cycled before, at least 4 or 5 times further than I had ever cycled. And I phoned them up and they said yes, they had one in stock. So I hopped on my bicycle and cycled, and it was raining and it was miserable, but just the thought that I would be able to get my hands on one of these pushed me through. And I got to the shop and they said, oh yeah, we've got it. And it was in a display case in the box, and the lady took the box out of the display case, and to her dismay and my dismay, the box was empty. Somebody had walked off with the calculator, and probably a staff member, and it was just the box. So yeah, cycled all the way home again, empty-handed. Luckily it was just shortly after that a shop much closer to us got stock, and I finally got my hands on one. So I used this throughout high school. It has some features which weren't actually allowed in high school, so it will solve simultaneous equations, which wasn't allowed, but I managed to sneak it through. When I was doing computer science at high school, we had to do decimal to binary conversions manually, so that also technically wasn't allowed, but again, kind of snuck it through. No, didn't get noticed. Yeah, so that served me well while I was a serious programmer. So we're talking now late 90s, early 2000s, when I was in school, and afterwards when I went to college. And after college, and I decided that I was going to leave IT because the IT bubble kind of burst. I moved on. Well, firstly, I went to university and I studied finance or investment management, and we had to get a suitable calculator. Most of my fellow students went out and got the bog standard HP financial calculator. I do have an example, but not handy. It's the gold and black one, yay size, the usual standard, de facto standard. But then I thought about it and I thought, well, that calculator's got all the functions built in, but if you wanted to do anything above and beyond those built-in financial functions, you couldn't. So I chose rather to go for this one, which is the Sharp EL 5120, which is programmable. So I could program in all the formulas, equations, whatever I needed, to bring it up to the equivalent of the financial calculator. And this was on the list of approved calculators, so I could use that at university for my finance degree. This one still works if I can find the on key. This one is actually working really well. There's a bit of LCD deterioration in the corners, but for the age, it's doing really well. So that saw me through 4 years of university, and then I don't think I really used calculators much for the majority of my career. And then about 10 years ago I went back to university to study undergrad degree in astrophysics, and neither of my two shops were allowed because the one had all those constants in, which in my degree that I was studying we had to remember out of our head, and the other one being programmable. Of course, you could program in really complicated programs in there, and yeah, that wasn't allowed. We had to do everything by hand. So rather ironically, I had to go backwards, and this saw me through my 4 years of or university the second time round. This is just a bog standard sharp. I don't think there's anything fancy about it. It's 2-line display. It's also got the conversions to binary, decimal, octal, etc. In fact, I think all of the sharps now have those conversions. Also got the 6 memory banks. So a lot of what was very fancy back in the day for this is now just standard across the whole sharp range of calculators. And then when I was finished with university and there were no more constraints on what I could use. Hello. I always found this cover a bit tricky, bit of an odd one that. So once I was no longer constrained by what I could use, I went out and got myself this baby. Everybody should know this. This is the HP Prime. This is the first version, so it's got the keys which are rather hard to read. There's a newer version, it's got more memory, a better processor, and a better keyboard layout. So yeah, this one is, I want to get the new one. This one is pretty much brand new. I only use it occasionally. It's got some really neat features. It's got like 3D graphing. I don't know if I'll be able to find that easily. So every time I use it, I have to kind of remember how to use it. So we've got graph 3D, so I've got there an equation in, and if I hit plot, yeah, there we go. So it starts plotting that in 3D, and it's got a touch screen, which is really nice. So super calculator. But would never ever be allowed in any educational environment. But it serves me great day to day. So, what is today's video about? Brings me all the way back to my original, which is totally dead. I've put new batteries in, so I know it's not batteries. So what else could it be? Now these don't have a lot of electronics in. It's, you know, a chip and a blob, and there's one passive component. There's a electrolytic capacitor sitting roughly around here, if I remember correctly, and that's it. So whatever's gone wrong has to be more mechanical, I think, than electrical. And, you know, doing a bit of reading online and reading about, you know, what can go wrong with old LED displays or old calculators. The most common cause is that the ribbon cable connecting the display to the PCB that's actually got the, you know, the chip and the blob on, that ribbon cable stops making good contact. So that can be one area, and the other possible area is the ribbon cable between the keypad and the PCB. That can also lose connectivity or make poor contact. But then at least you should get something on the screen, but you'll find that some keys don't work. So since this is totally dead and I put it away working, I think it's just the display. So let's get this open and I will show you guys. Well, let's see. I will attempt to show you how it gets fixed. So the tools you need for this, it's got lots of little screws, so magnetic screw dish, miniature Phillips, and a pry tool of your choice, which is, depending on how much you value your calculator, that's optional. This has got a lot of sentimental value for me, so I will pry the case open gently. But if you don't particularly care about yours as much, then and you've got faith, you can just pry the two halves apart. Okay, so let's jump straight in here. So there's 2 screws on the back, so pop those out. And then you'll see that the top comes apart a little bit, and then down the side there are 3 clips on either side holding, so you could just yank these 2 apart, but I don't want to risk any breakages. So what I'm going to do is just get this little pry tool in here and slide it down until I hit the first clip, and there I can see it, and there we go, got that one. And I'm just going to work my way around and cut back in once I've got that back off. Okay. Zero damage, and there we go. Now we're inside, so yeah, there's your chip in a blob, electrolytic capacitor. It's a 10 microfarad 16 volt from memory. I'm not going to replace that because it looks fine to me. So the 2 areas that we'll be focusing are this ribbon cable connection here, so that's looped round from the LCD display, and that's where it connects to the main PCB. And we'll have to take this board out, which has got the matrix on for the keypad, and we'll have to take the display out to get to the ribbon cable that connects those 2. And then what we're going to do is pretty much just apply heat with the iron, and pretty much like reseating an IC that's soldered, or a surface mount IC. It's pretty much what we're doing. We just making sure that these are making good contact. Okay, so next out are a lot of little screws. So let me get my dish back in here. So okay, so now we just need to pop. Oh, okay, so here I suggest that you put in your little pry tool and separate the membrane, or the rubber membrane for the keypad from the actual board that's got the contacts on, and leave that in the housing just to keep all the keys in place. Yeah. so there we go, we've got that out. Back down and around. Okay, and if we move that down so we can see, here's the first area that we're going to be working on. Okay, so I've already got my iron on, and okay, so for your iron, make sure that it's on, start with a medium heat, no steam. I don't even have water in this one. Yeah, you definitely don't want to get water in here, you just want heat, but you don't want it too hot that it actually starts melting the plastic. All we want to do is kind of reseat I'm not sure if it's glued on or soldered, but yeah, the heat reseats that. Okay, so just going to switch off the iron, use the residual heat, make sure that the temperature is good. Okay, so switch that off. So this is now piping hot, so let me just switch here. So I'm just going to be using the tip over here and using a backwards and forwards motion. Don't sit in one spot too long. So yeah, let's get in there. Let me first make sure that all these wires are well and truly out of the way. Okay, so all we do is run that backwards and forwards. Okay, I'm going to put it down so I can put some pressure on. Okay, and you do that for, well, it's an arbitrary amount of time. It's not like a, a solder joint where you can actually see the solder melting. If it doesn't work first time round, then either go over it longer or bump up the temperature. But just be careful that you don't get your iron too hot, that it starts melting the cables. In fact, try and avoid contact with the ribbon cable if you can. Okay, so let's put that iron aside for a while, and that is nice and hot, but too hot. And then I want to do the same on these here. Okay, so still holding down the rubber membrane to stop the keys from coming out. I'm just going to apply heat across this one. Let's get in with the tip onto the other row as well. So kind of doing these two in one. I'm putting quite a bit of pressure downwards. I've hit my thumb now twice with the iron and it is burning. So just be very, very careful. There's again. Oh. Okay. Okay, let's leave it like that. Okay. So let's take this out altogether, and I just want to give this a quick clean. I mean, not a clean, just a blowout. That's probably good while those connections cool down. Okay, there we go. So I just wanted to get that ring lifted a bit better. Okay, so there's still dirt in here. While you're in here, you may as well clean it as best you can. So tip that and see what the plastic is looking like. Okay, so I'm happy with that. Okay, now we can start reassembly. So that's just the reverse of how we got it out. Get the screen in, it just plonks back in. Very gently tip this around. Okay, get that board, the PCB under. There's a little plastic tab there and a little plastic tab here. So you just want to get the PCB under those. Okay, looks like I've melted some sellotape here a bit. But no harm done. Okay, so let us get our terminals back in. So that is positive, and then route the cables. Route the cables. So I'm just going to give this one a bit of pressure. Oh, that went in a bit deeper than before, but that's nice. Get that cap, make sure the cap is down. Then get the negative in, which goes under the that round sticker. So let's see, let me get you in nicely, easy, and then just apply pressure and get that sticker back down. Though once the batteries are in, they will they'll apply more than enough pressure. And then this cable, also just reroute that, not reroute, route it, so that it's not like over here, it's not hanging over where the two halves of the casing come together. So I'm just going to gently nudge that out of the way, and yes, that is clear. Okay, so before I go and put all those 1,000,001 bolt screws back in, let's pop some batteries in. It's quite interesting that they made this calculator and they made it really difficult to swap the batteries. So they pretty much expected it to run from these two like button cells for its lifespan. I always found that interesting, that it wasn't easier to replace the batteries. Though granted, I never needed to replace the batteries while the calculator was in active use. And these you just push down and they kind of stay there. Okay, now very carefully applying pressure onto the backing plate of the keypad. Oh no, keys are falling out. So I haven't got the pressure right, it's not sitting properly. There it is. Okay, let me just make sure. No, still something is not right. Something is not right. I'm gonna have to go underneath. There we go. Working perfectly. 52 times 2 is 100, so I'm going to close the brackets. 104, and that completes. Okay, so 85. This is just something easy. So 500, stow in A. Nice, it gives then it shows you goes that's gone into A. 1000 will stow into F. Oh, it calls it Y. That's interesting. Even though the letters say A to F. Anyway, so then we can say recall A plus recall Y, and yeah. And then our constants. How do we get our constants? So if I pull up the chart, let's say gravitational constant is constant O2, constant, so then it just asks for 1 to 32, so we want O2, and there we go, our gravitational constant. Lovely. We've got gravitational acceleration as well, so that's constant 3. This we should know, it should be 9.8 here. 9.8 meters per second to the power of negative 2. And let's see what constant 25 is. Don't know that one. Do not know what that one is. Let's try some conversions. So 60 miles, and I want to know how many 60 miles is in kilometers. We go 07, 96.6 kilometers. So that has worked. Judging by how clear the display is, and that I put much more pressure on that display ribbon cable, I suspect that was the issue, that the calculator was actually always functioning, just not actually displaying anything. Okay, so now it is a case of getting all the screws back in. it's going to work like that. So we just apply force, click, 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 click. That's all in.